Have you ever started digging a hole and wondered how far you could dig? What about digging all the way through the planet, like in a cartoon? The diameter of the Earth is about 7,917 miles at the equator. If you're only using your arms and a shovel, you wouldn't get very far. Even with the most advanced drilling equipment, you would only be able to go a few miles down. The Earth may seem huge, but in comparison to other planets in the solar system, our planet is on the smaller side. For example, Jupiter, which is the largest planet in the solar system, has a diameter of 86,900 miles. On the other end of the scale, Mercury is our smallest planet with a diameter of only 3,032 miles. Today, digging a hole all the way through to the other side is not possible, but let's conduct a thought experiment. Our goal is to dig all the way through the Earth and come out on the other side. While it's not possible today, it may be possible with tomorrow's technology. For our experiment, we'll assume we're living 100 years in the future. It's the year 2123, and we now have the technology to build a ship that can travel deep underground. We don't know what kind of tech will exist then, but based on today's advances, we can predict what kind of ship we would be able to build. Building a ship is only half the battle. We also need to consider other factors when drilling a hole this deep, specifically temperature and pressure. The further down we go into the Earth, the hotter it will become, and the pressure will be intense. Imagine all the weight of the Earth above us and pressing down. A soda can would pop in a nanosecond and be squished to a tiny wafer under all that pressure. So it's critical to design a ship which would be strong enough to withstand the pressure and temperature in the Earth's interior. Building this kind of ship is an enormous engineering challenge. Even in the 22nd century, it will require advances in many areas of technology, including materials science, propulsion, navigation, and life support. We would need to use high-tech materials and construction techniques, such as superalloys, nanocomposites, and 3D printing, to protect against radiation and electromagnetic interference. The hull, or the outermost part of the ship, would need to be coated with a specialized layer. This material can be lead and aluminium, or made of materials such as polyethylene terephthalate. This layer is important because radiation is harmful to human health. If the ship is not protected, you would be exposed to potentially lethal doses of it at the center of the Earth. Next, we would need to design the propulsion system. This engine would have to be capable of generating enough power to drive us through the Earth's interior. It will require the use of advanced reactor technology, such as fusion or antimatter reactors. Of course, as we journey deeper, we don't want to get lost. To properly map our course and avoid obstacles, the ship would need a sophisticated navigation computer. This system would use advanced sensors, such as gravimeters, seismometers, and magnetometers. Strong artificial intelligence algorithms would be available to us in the 22nd century. These AI bots will be able to quickly analyze the data and make decisions in real time. It would take many years to build such a ship, and during that time we have to study and map our path. We would have to understand all the regions that make up the inside of the Earth. These layers are the crust, mantle, outer core, and then finally the inner core at the middle of the planet. Now, finally, we're ready to start the journey. Let's imagine that we start digging in New York City. Our AI activates our drilling system, and the drill bit, which is made from a special heat-resistant material such as diamond-tipped steel, starts to turn faster and faster. The drill pierces the soil, and we descend immediately into the crust. The Earth's crust is composed of solid rock and is relatively brittle, making it easier than the deeper layers to drill through. This first layer is small and makes up just 1% of the Earth's total volume. It also varies in thickness from about 4 to 25 miles, or deeper, depending if you're in the ocean or on the land. The solid rock is divided into several large plates that move and interact with each other. As they do this, it results in geological activity such as earthquakes, volcanic eruption, and mountain building. Even though it's a very small part of the Earth, the crust holds everything you see around you. This includes plateaus, valleys, and canyons. Even the deepest underground cave that you have ever explored is located in the crust. It's home to many of the planet's important resources, including water, oil, gas, minerals, and fertile soil. Did you know the deepest hole ever dug into the Earth is the Kola super deep borehole, located in Russia? It was drilled by the Soviet Union in the 1970s as part of a scientific project to study the Earth's interior. The hole reached a depth of 7.5 miles and is the deepest man-made hole in the world. You may be wondering if scientists found anything strange that far underground. Was it really the well to hell, as some people named it? Did it really drill so deep that it broke through into hell? No, that's just an urban legend. It is true that strange sounds were heard from deep in the hole, but those sounds weren't from unknown creatures or supernatural forces. Scientists confirmed that those creepy sounds were actually caused by drilling equipment and normal seismic activity from the Earth's mantle. If there were really demons or other monsters in that hole, we would all know about it by now. Despite the Kola borehole's depth, it did not penetrate all the way through the Earth's crust. But the good news for our experiment is that we live in the 22nd century, and we do have the technology to drill deeper than ever before. So, let's continue and enter the next layer inside the Earth, the mantle. If you want to know what we find as we continue to dig using our 22nd century digging machine, click on the next video.